Hi everyone, and in this video I'm going to discuss one of the most important chapter in the physics, that is motion in a straight line. Motion in straight line. Okay. So in this year and this chapter is comes under one of the main branch in the physics, that is the kinematics. So I'm going to discuss the kinematics branch. This is a sub branch of physics. Kinematics one, it is sub branch of physics. And before that, here we should know, what do you mean by mechanics? What do you mean by mechanics? So mechanics is a branch of physics. It is a branch of physics. It is a branch of physics. It is a branch of physics in which we study motion of the body. Study motion of body. So when the body which is moving in one direction, so we are going to discuss some physical quantities. And that physical quantities we are going to discuss, and also we make some relation between that physical quantities. All we'll discuss in the one branch. The branch is called as the kinematics branch. The kinematics is a branch which is comes under mechanics. So kinematics. Okay. And 1D means here the body which is moving in only one direction, that is called as a one-dimensional motion. So kinematics, now we can say that the kinematics is the branch of physics in which we study the motion of the body. And in this kinematics here, we are going to study some physical quantities which are involved in the motion of the body, which is moving in a straight line. For example, this is the body is there, A, and this is the body A point, P is the body, and the point particle P starts from A and ends at B. Whenever the body which is moving from A to B, it covers some distance. So it covers some distance, it will take some time, and it has some velocity, and it has some initial velocity and final velocity. So we are going to discuss all these physical quantities, and we are going to study about all the definitions of all physical quantities, and also we make relations between all the physical quantities. That is called as the kinematics. So now in these topics here, we're going to cover rest and motion, and second concept, types of motions, and the path and path length is also called a distance, displacement, speed, and types of speeds or classification of speeds, and velocity and change in velocity, acceleration, equations of motions. So in this channel I'm going to discuss all these topics, and in this video I'm going to discuss the first concept, that is the rest and motion. So now, what is the rest? What is rest? Rest means, so for example, so if you take any body which is called as a P is the one body, and which starts journey from A to and B, and B to and C, and C to D. Okay, so they start a journey from A to B and B to C and C to D. Okay, so for example, at t equal to 0, so the position of the particle P does not change. So after some time, t equal to 1 hour, after 1 hour also the position of the particle does not change. So the particle which is remains same at the same place. So that means we can say that the position of the body does not change with respect to time is called as a rest. The position of the body, the position of a body, the position of a body does not changes, does not changes, does not changes with respect to time, with respect to time. So the position of the body does not changes with respect to time is called rest. This is the definition of the rest here. But actually the definition of the rest, it is not like that here, because here, so in the on the earth, nobody on the earth is not at rest, because here earth is revolving. So earth is revolving around the sun here, around the sun here. That means that as earth is revolving, the bodies which are on the earth also moving. So therefore we can say that no body is not at rest on the earth. So our scientists, so to define the rest definition, our scientists have found that one of the word in the physics here, that is a frame of reference. Frame of reference. Frame of reference or reference frame, both are same. So reference frame, reference, so reference frame, reference frame. So what is the reference frame means here? It is a background, it is a background, it is a background, it is a background from which we made observations. We made observations, that is called as a frame of reference. Okay, for example, to understand this frame of reference here, I can take simple example here. So this is my classroom here, this is my classroom. In that every classroom here we have some board, so blackboard or green board, whatever it is here, the blackboard is there. Okay, so according to this blackboard, according to this classroom, and the blackboard is always at rest according to this room. So this classroom is taken as a frame of reference. Frame of reference. This is the frame of reference. This is the background. So from which we made observations. It is a reference frame. Reference frame. Reference frame. Reference frame. So according to this frame of reference here, the blackboard is at rest. Okay. Next, but some other example. There is a person who is on the moon. There is a person who is on the moon here, and according to the person who is on the moon, and the blackboard is in motion, because here, so this blackboard entire setup which is on the earth here. So as you know that, so earth is revolving and the blackboard also moving. So therefore we can say that here, we can say that the blackboard is blackboard is in motion. Okay, that is the concept of rest here. So rest means here, so the position of the body, so does not changes with respect to time in a frame of reference. 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 So we have to add this word here. Then only it is the exact definition of the rest here. So the position of the body does not changes with respect to time in a frame of reference. That is the definition of rest here. Okay, I hope that you understood the definition of rest. Then go for the, so this is a rest and motion here, and reference frame. It is a background from which and we made observations. That is called as a frame of reference. Rest definition: if in a reference frame the position of a particle does not change with respect to time, then the particle is said to be at rest. Here listen, and here we have some examples are given here, and the books are on the table here. So books kept on the table or at rest with respect to its surroundings. With respect to surroundings here, for example, this entire table is kept in a classroom here, and according to this classroom here, so the books are at rest on the table. So we can say that so the books is at a rest. Book is at a rest. Next here, next is here motion. Next definition is motion. So simply we can say that here in a frame of reference we have to add in a reference frame, in a reference frame, in a reference frame, the position of a particle, the position of a particle changes with respect to time, with respect to time, with respect to time. Then particle is said to be in motion. Okay, for example, simple I can say here, this is my classroom here, this is my classroom here, and at starting condition, this is my position. After some time, this is my position. After some time, this is my position. That means for every 1 second, so the position will changes with respect to time. That's why we can say that the body which is in motion. Okay, this is about the motion here. So now go for the other slide here, the motion. So an object is said to be in motion if it changes its position with respect to time. With respect to time in a frame of reference, or with respect to its surroundings. Surroundings means reference, frame of reference with the time. Okay. Yeah. Examples: moving cars and buses, trains, cricket ball, etc. Now all the planets revolving around the sun. Molecules of a gas in a motion above 0 degree Kelvin. So all are in motion with respect to surroundings. So therefore we can say that all are in motion. Okay. Now next concept is here the difference. So after knowing the definition of rest and motion, now we can make some difference between the rest and motion here. So first one here. So first point we should write so definition of the rest and definition of the motion. Okay. So these questions will be asked in a examination, script examination. So we need to write like this. So form a table and divide the motion of the concept of rest and the concept of motion here. Okay, a body is said to be at rest if its position does not change with respect to a fixed point in the surroundings. And this is a definition of the motion. Just we have discussed. We can write this point. Okay, examples you can write that already we have discussed now, and these are the points. All the points we have to discuss. Okay, then you can write according to the exam. You can write. Okay, according to the exam, you can write all these points in our examinations. Okay, next point. Next here, last topic, last one in this video. Rest and motion are relative. Rest and motion are relative. Relative means here the meaning, that is rest and motion both are relative means here. So it is not same. They are not same for observers. Different observers. They are not same means rest and motion are not same for different observers. So why? So what is the exact meaning of that relative? Now we are going to discuss. How can you say that the rest and motion are relative? Yeah. Listen here. Listen here. For example, same example, whatever the example I have taken just now, same example I will take here. So this is my classroom here. According to the classroom, the blackboard is at rest. But according to the person who is on the moon here, the blackboard is not at rest. The blackboard is in motion. It means here there is an observer in the classroom. There is an observer on the moon. So observer 1, observer 2. So according to the first observer, the blackboard is at rest. According to the second observer, so the blackboard is in motion. That's why we can say that rest and motion relative. So both are not same. Both are not same for observers, for different observers. Okay. If it is same, therefore we can say that rest and motion both are observed. But in this case here, they are not same. That's why. So motion and rest both are relative. So motion and rest are both are relative. Motion and rest are relative. Okay. I hope that you understood my today lesson, and we'll discuss the remaining topics in the next video. And thank you very much.